I now have the keyboard completely dismantled. I've taken the encoder bars out. Whatever grease was on there has mixed with whatever's fallen down into the keyboard over the years and turned to some sticky goo, so that explains why these weren't moving freely. The springs that operate them are very small to keep the key pressures down, but it does mean that any dirt and muck that gets in here does tend to stop these moving freely. I've completely stripped this down. The only things I'm not taking off, as I mentioned in the videos where I was doing the main chassis, there are these stop adjusters on each end of any main assemblies, and they're adjusted in the factory when these things are made, and these abut other parts of the machine, and the idea is that they give very good registration between this assembly and the one next to it. So in other words, there's one of these that presses up against the transmitter and one that goes up against the identification unit, and the spacing is critical, so I won't be moving these, but I've taken everything else off. I've started cleaning the bits and they are coming up quite nice, but it has taken 4 or 5 hours to get this far with cleaning. There are a lot of pieces in this keyboard. I've cleaned all the glasses out of the keys. There's still a bit more cleaning on some of them, but they're mostly done. I've cleaned the keycap surrounds. These are the ones that have little bend down tabs, so some of them were quite difficult to get off. I'm just hoping I can get them on without the tabs breaking off. If the tabs do break off, then I'll have to find an alternate way of securing them, but fingers crossed they should go back on okay. And now it's just a case of cleaning everything and then starting to reassemble. There will be some adjustment required once it's all put back together again. There's no way around that really when you take it completely apart, but hopefully it won't be too difficult. So hopefully I can get this part of the assembly back together again and fully functional, and then we can start looking at the other elements within the keyboard. Okay, so everything is finally clean. I've made a new set of keycaps and I'm ready to start reassembling the keyboard encoder unit. I'm in the process of reassembling the encoder section of the keyboard, and I thought this might be an ideal opportunity to show how the encoder bars actually work. Now, as I said earlier, this is a 5-bit machine, and the observant may have noticed there's actually a 6th bar here, but that's just an indexing and latching bar, so you can ignore that. The code is actually set on these 5 pins that are attached to the encoder bars. And the way this works is, in the transmitter unit, which sits at this end of the keyboard, there's a bar that is used to pull these 5 encoder bars across, and they're held there waiting for a key to be pressed. So this part of the mechanism is a kind of latch release system. So whichever of the keys you press, it will release the encoder bars. But when you press the key, as well as releasing the encoder bars to allow the return springs to pull them towards the right hand side of the keyboard, there's also a tab on each of the keys that will drop down into these slots. So let's assume that this plate is one of the tabs, and normally they sit above the encoder bars in this position, and when you press a key down, the bar is pushed down into the slots in the encoder bars. So if we look at the far left hand position, I'll pull the encoder bars across, so this is the position they'd normally be in, waiting for a key to be pressed. And if I drop a plate down into the end slot, what we end up with is a code. The first bar has been allowed to return all the way to the right. The second bar is being held because it has a tab on the encoder bar, and the remaining three again have been allowed to move all the way to the right because there aren't any tabs in those locations on the encoder bar. And I'll get the manual for this teleprinter, and if we look at the code for the binary values that each key represents, I happen to know that the left hand key, or the one we're looking at, is Q. And if we look at the code for Q, it's this one. The black dot represents a mark and the white dot represents a space. Ignore the first black dot, that's the start bit. So the code we're looking for is 10111. If we go back to the keyboard and I relatch the same value, then what we have is the code we're looking for, which was 10111. If I do the next key across, the next key would be an A. So if I move this one slot along, so in other words I'm pulling the bars to the right, and that's the position they'd normally be held in, waiting for a key to be pressed. We press the key, that pushes the tab down into the slot, and it also unlatches the bars to allow them to spring back or try to spring back towards the right. So this is an A, and if you remember from the previous character, when the bars are to the left it's a 0, when the bars are to the right it's a 1. So this is giving us a code of 00011, and if we look at the manual again, we can see that for an A we should get 00011, which is exactly what we're getting. So that's how this works. It's just a series of encoded bars with tabs. These bars are normally held on a latch towards the left hand side of the keyboard. On the right hand side there's a spring on each bar that's trying to pull it back towards the right. So when the bars are unlatched, that is when you press a key, they all try to move back towards the right. And those that are not allowed to move back towards the right represent a 0 value, and those that have moved back towards the right represent a value of 1. And that code is scanned by the transmitter and sent out as a series of binary digits. I'll come back and look at this in more detail in a later video, but I thought it would be interesting at this point, while it's fully disassembled, to see exactly how the encoding works and how the keys interact with the encoder bars. Okay, so that's the keyboard encoder reassembled. As you can see, it does look a little bit better than it did before. I've got one keycap to straighten, I haven't put it on quite square. I made a new set of inserts. The old ones, as you may have seen in the previous video, were yellow and beyond repair. As ever, the mechanisms like this are slightly more complex than you may think they need to be initially, simply because they have to fulfill several requirements. One of those is this has to buffer the key press before it's released by the mechanism. The reason for that is if you just press a key very briefly, it will start trying to send that character, and the transmitter will start processing the character. But if you were to release the key and the character wasn't buffered, and all the selector and encoder rods went back to their home position, then you would get scrambled data going out of the machine. So the way this works is you have these two bars. You've got a latch bar and a clear bar, and also you've got a latch bar which is bar number 6. So you have the 5 encoder bars, and there's another one behind, and that's used to latch the character or the key that you press until it's been processed. So where this would work is these encoder bars pulled across by the transmitter, but the latch bar is also pulled across. When you then press a key, assuming that the block latch is undone, you then press a key and the transmitter would then release the encoder bars. So if I now release this key, you see the encoder bars stay where they are because they've been latched by bar 6, and then you can see that the actual code has been saved in the encoder bars, and that can now be processed by the transmitter. Once it's been processed, the transmitter will release the current key, which as you can see is still down, but when I release the catch, you see it pops up and all the bars have gone back to their home position. They would then be pulled across into their waiting for a new character position, and the entire process would start again. There's another bar down here, you can't really see it now, but it's the bar with all the holes in it, and that's used to detect that a key has been pressed, and that is what triggers the mechanism to start processing the key. So it's all very clever. This arm here is for the character counter, and then on this end, this is where the encoder or reply encoder sits. We'll look at that in a separate video. So that's it for this video. I can now get this refitted to the keyboard chassis. So I'll just grab the keyboard chassis. Okay, so as you can see, I've repainted this. This unit sits in here, of course, but before I refit it, I'll refit the adjustment tabs that I mentioned earlier, give it a final clean, and then I can start reassembling this part of the keyboard, and I will do that in the next video.